Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 11. We are continuing our discussion of trigonometry. So, what we're going to do in this video is focus on finding points on a circle with trig functions. So, what we want to do is say, let's see here. If we are given, let's start with an example. So if we're given an angle of about 2 pi over 3, and we're told that the radius of our circle is equal to about 4, then if we want to find what x and y equal, then we can recall that x is going to equal r cosine theta, and y is going to equal r sine theta. So if we want to solve for x, we know that r is 4, and we just gotta plug in a 2 pi over 3n for cosine, and for y it's something rather similar, except with sine. So at this point, we should have the unit circle memorized if you've been following our series. It's something I highly stress that you do. And so when we think about cosine of 2 pi over 3, we know that's in quadrant 2. And since it's in quadrant 2, x is negative. So that means we know that this value has to be negative. And let's see here. We, in fact, are going to have 4 times negative 1/2 for our cosine. So that means our answer for our x is negative 2. And for y, let's see here. We have, since we are in quadrant 2, y is going to be positive. So when we consider sine of 2 pi over 3, that's going to be square root 3 over 2. So y will equal, not 4, but 2 root 3. Alright, there's our answers. That's our xy coordinate. So let's write that out. There we are. We'll box our answer. Another type of question we can ask ourselves is something like this. So if I give the point, let's think of something good. How about 10 over 11 comma root 21 over 11. So the question is the following. Is this point on the unit circle? Is this point on the unit circle? Well, if we remember the unit circle, right, we said it had this equation, x squared plus y squared is equal to 1. Now, we looked at several values. Like if theta was pi over 4, we know the x and y coordinates were square root 2 over 2, comma square root 2 over 2. And similar with pi over 6 and pi over 3, we saw it would alternate between a half and root 3 over 2. But what we're given here is this point, that doesn't look like either of those values. Any of those 3 values there, right? It doesn't look like a root 2 over 2, doesn't look like a root 3 over 2, doesn't look like a half. So is this on the unit circle? Well, to answer that question, we have to think back to our equation here. So what our strategy is going to be is, if we plug in our x and y value here, right, because this is an x coordinate and this is the y coordinate, if we plug these values in for here and here, then we can see whether it's equal to 1, right? If it's on the unit circle, the sum of these squares here has to equal 1. So if it's something else than 1, then you know it's not on the unit circle. So what we need to do is take our 10/11ths and square it and add root 21. That's a pretty bad 21. Root 21 over 11, and we square this quantity. Well, let's see here. this is 10 squared over 11 squared plus root 21 squared over 11 squared. So we get 100 over 121 plus 21 over 121, or 121 over 121, which is 1. So yes, this point is on the unit circle. So just to re-emphasize, if at this point right here, once we add these quantities together, you get something that is not 1, then you know it is not on a unit circle. In our case, this quantity boxed in green is equal to 1, so we know it is on the unit circle. Alright, so that's two kinds of questions we can ask about points on circles. One is finding xy coordinates with a given angle and radius, and another one is a point on a unit circle. We can ask another type of question like this one. No, let's not use green. So I could, for example, say that how about cosine theta is equal to 4/7, and we're told that theta is in, well, let's make that negative, yeah, and theta is in quadrant 3. Alright, and then our question is going to be, what is sine of theta equal to? Alright, so first we must review what's going on with our angles and xy coordinates on our unit circle here. So let's draw our unit circle. That's alright looking circle, not bad. So when we think about quadrant 1, right, so this is quadrant 1, 2, 3, and 4. And just to review, in quadrant 1, we know that x is going to be positive and y is positive, right? And just for quadrant 2, x is negative and y is positive. For just any value in this quadrant, x will be negative but y is positive. Quadrant 3, on the other hand, both are negative. In quadrant 4, the x values are positive and the y values are negative. Now, since sine and cosine are directly related to x and y on a unit circle, right? So on the unit circle we had sine theta is equal to y and cosine theta was equal to x. This means that our sine pattern here for all 4 quadrants, sine and cosine will follow. So cosine is positive in quadrant 1, sine is positive quadrant 1, cosine is negative quadrant 2, sine is positive in quadrant 2. Both negative in quadrant 3. Sine will be negative in quadrant 4, but cosine is positive. So when we think back to our information here, we're told that theta is in quadrant 3. This tells us that sine theta must be negative because the y coordinate here is negative, and since the y coordinates are negative, sine must be negative. So this is an important piece of information right here. Now the other thing we want to think about is we need to draw a picture, right? We need to draw a picture with this cosine theta. So since we're in quadrant 3, I'm going to focus on this bottom left corner of the graph. So we have our angle here. Here's our theta. And what is happening is if we think about rewriting this cosine here, if we remember our cosine theta is equal to x, well, the radius cannot be negative, which means this negative has to stick with the x. So we can rewrite this. 7 cosine theta has to equal -4. So what this means is our x is going to be -4 and our radius has to be 7. So we're going out this way, -4 units, and then we are going down. Well, that's the question mark. We don't know what y is, but we do know that this right here has to be 7. So alright, so we need to find this y coordinate here. Maybe instead of a question mark we'll scribble that out and use a y, right? We're looking for y because we know what r is. Let's zoom out a little bit. Yeah, there we go, that's better. So we know what r is because in this setup here, if we multiply both sides by 7, we see that r is 7. So then to solve this, what we can do is Pythagorean Theorem. So Pythagorean Theorem is a squared plus b squared is equal to c squared, where a and b are the two sides of the right triangle, right? By design, this is a right triangle, and c is the hypotenuse. So if we set this up, we'll have y squared plus -4, that quantity squared, is equal to 7 squared. That is y squared plus 16 is equal to 49. So we subtract 16 from both sides. And that gives us y squared is equal to 33. Square root. Y is going to equal plus or minus root 33. We get the plus or minus because when it's from the square root, whenever you square root, it's always plus or minus. Depending on what, in our case here, depending on what quadrant we're in, that will determine which sign we want to use. So we're told quadrant 3. That means sign has to be negative. That means we want the negative. We don't want the positive, so let's put an x on the positive. Alright, so that means y is equal to negative root 33. So we can plug that in. Our sine theta is equal to y, so 7 sine theta is equal to negative root 33. Or, once we divide out that 7, sine theta will equal negative root 33 over 7. Let's box our answer. I think I forgot to box our answer in one of the previous examples. Alright. So, just by drawing a triangle here, keeping track that cosine is r, cosine theta is the same thing as pretty much x over r, or if you want to think r cosine theta is equal to x. By putting those values in relation to a triangle, we use the Pythagorean Theorem to get an answer. Whether our answer for sine was plus or minus depended upon the quadrant. So keep this information right here in mind, okay, about the quadrant. Alright. With that, I think we're going to call that a video. We're getting close now for, actually, yeah, next video, I think we're going to start with graphing trig functions, which is super exciting. Alright. Thank you for watching this video. If you've been enjoying our content, please subscribe. Consider supporting us on Patreon. Thank you for joining the math party, and I will see you next time.